Greetings, folks. Professor Fiore back. And today we're going to talk about AI circuit design. We're going to have some fun with this. All over the news, of course, no matter where you're getting your news from, there's always something about AI and how it's going to change everything. And I think there's a lot of unfortunate reporting. People get the wrong idea of what's actually going on here. Perhaps a bit of hype, too. Big surprise there. So what can a person do, particularly someone who's sort of a newbie with circuit design, and they're thinking, hey, I'm going to use one of these AI engines to create a circuit for me. Take some of the drudgery out of this, right? Well, let's just see what we can do. Okay, so I'm going to start off looking at a couple of different circuits. All right, so I've got two very simple things here. Well, one very simple and one not too complex. So the first one is just a very simple 2-to-1 voltage divider. That's it. It just takes the input voltage over here, divides it in half at V out. Okay, a couple of 100 ohm resistors and a 10 volt source. Assuming the load out here is a lot higher than this 100 ohm, we should get 5 volts. Okay, fairly straightforward. Second thing, basic schematic for a single stage Class B audio power amplifier. Nothing too fancy here. These are the kinds of circuits I've simulated in many other videos before using Tina TI like I have right here. You can find these in many different places, right? Much fancier versions, you have multiple NPNs and PNPs. This doesn't have a preceding voltage gain stage. This is just a very simple kind of single output stage. Boom, there you go, let's go. Okay. So the first question is, if I want to do either of these, suppose I just went out and did nothing to do with AI, but I just did a simple web image search. What am I going to get back? Am I going to get back schematics that look something like this? Maybe with values, maybe not, but something that I could at least start with. All right, so that's exactly what I did. I just did a little DuckDuckGo image search, and let's see what we wind up with. So one of the first things I got for the voltage divider was this. Perfectly acceptable. There's my source, a couple of resistors. Now, it's not set up for a 2-to-1 voltage divider, but at least it's a voltage divider. And I'm sure if we did a much more extensive search, we could probably find one that was set up for 2-to-1 or maybe had an equation or something like that. But this is straight out of an image search, right? And I repeated that process with that second prompt for a Class B audio amplifier. And this is one of the things I got, one of the very first things I got. So again, pretty standard. This includes some little feedback resistors in the emitters. And the input signal here comes into the PNP rather than in the middle here. We don't show coupling capacitors or anything like that. There's no values. It does use a split power supply, compensating diodes. Perfectly good. It's a great place to start, right? Go back to what we were initially going for, okay? And then, boom, that's what we see on an image search, okay? So again, you could pour through these images and there would be, dozens and dozens, and you would kind of get maybe a feel for what the commonalities are, and you could make a circuit based on that, right? And that's sort of the idea that people have for AI, an image generation, right? You would say, okay, it sees, thousands, tens of thousands, hundreds of thousands of schematics like this for a little Class B amplifier or a voltage divider or some other electronic circuit. And it's going to kind of figure out what the commonalities are. That's the artificial intelligence, right? That's the intelligence of this. And it's going to give me something. And then maybe I can refine it by specifying things like what I want for the output power or the power supply values or an input impedance or, et cetera, et cetera, et cetera, et cetera. Okay? That's kind of the way people think about this. And I just have to sort of tweak that prompt to get what I want. And I think part of the reason of this is what we can do with images, sort of photorealistic images. So I did a little experiment and this should come as really no surprise to anyone as far as the output is concerned, I used a simple description of myself to see if I could get something, a picture of someone that looked at least coarsely like me. All right. And the prompt I used was basically white male engineering professor, 60s, thinning, balding brown hair, wire rim glasses. I had some little variations on that, but that was basically it. And, again, I went out to a bunch of different AI sites, AI image generation sites, and this is what I came up with, right? So there's my prompt. That's what I put in. And, I grabbed like a couple dozen, and I just sort of sifted through them, and I just sort of grabbed these three, all right? And it's kind of interesting. I'm just going to say a couple of things in terms of, okay, it's obvious, white, male, 60s, the hair, the glasses. But, I wonder what engineering professor did. But I will say this, look at the pictures, and what do you see that's common here? Okay. The first thing I'm going to say is, well, I don't look exactly like any of these people. Although I did have a professor way back when I was in school, who kind of looked like this fellow. But I would say that, if you stop by my office or lab or something like that, these wouldn't be odd like backgrounds. A little shelf over here with components on it, things like that. Notice, by the way, that they're out of focus, which would be appropriate for, a photorealistic kind of content using a camera. So that looks good. There are some kind of, to my eye, some interesting little things here. All these guys are wearing collared shirts. Nobody's wearing a turtleneck. And I'll be honest with you, this is pretty much what I wore for 40-ish years. I almost always, probably 95% of the time, wore a button-down Oxford shirt. I didn't wear a jacket. I didn't wear a tie. If in the winter I might wear a turtleneck. But, most of the time, if you saw me in the hall, in my office, in the lab, this is what I was wearing. Something like this, okay? Some interesting little detail that I'll throw out here that you might not be aware. The first thing I'm going to say is I think this first one is the most photorealistic. These are okay, not quite as nice as this. Another interesting commonality here is that they all have sort of bluish gray eyes, which I do as well. One of the prompts I used included blue eyes, and what I got back were people with these intensely alien blue eyes. I mean, it looked really freaky, but be that as it may, all right? There are some nice little subtle details here. For example, notice the reflections in the lens of this pair of glasses. Similar kind of thing over here, right? And I do want to zoom in over here on this first fellow, if you will. There are some interesting little details and actually some errors. What do I mean by errors? Well, the first thing I want to say is notice these are basically just shots of face, right? The reputation, if you will, of AI image generators for people who've dealt with these for a while, the very first thing they look for is hands. And they look at people's fingers. Because it's not uncommon. I have seen more than I can count images of hands where people have 6 fingers or 4 fingers, no thumb. Or maybe there's a finger that's orthogonal to their palm. Or it's bizarrely elongated. Or you see multiple hands, like people holding hands, and it's just like this spaghetti mash of finger and hand parts. And part of the reason for that is that the AI, even though we call it intelligence, doesn't really have any knowledge of the underlying elements. In other words, it doesn't really know what fingers are. It doesn't know their range of motion. It can only look at pictures and recognize shapes and say, well, that's this kind of thing. And remember, these are two-dimensional images representing a 3D reality. So it doesn't really understand that you can't have a finger bending in a certain way, or a thumb coming out of your palm or something like that. It knows what glasses are, but it has no idea what the purpose of glasses are. Like, why do people wear glasses? Now that might sound a little abstract, but I'm going to show you where this can screw up, where this can create problems. So anyway, there's a whole bunch of series of things like this. There really is no underlying understanding of things. And this is going to create a little bit of a problem for us when we try to go and design something using AI with this sort of technique. Now, I'm not saying that this can't evolve using a completely different thing. You wouldn't do this just by using the technique used in this case as a training database of lots and lots of images. That's not going to work for like proper circuit design, which we'll see. But anyway, I did say there was a couple of errors here I wanted to sort of zero in on. So I'm going to blow this up. I'm going to expand it. All right, so let's increase the size of this. This is kind of interesting. Okay, so the first thing I want to point out is look at this line on the cheek around the eye. You'll notice there's a discontinuity here, right? And this is the way it should be. If you wear glasses, you know this. You look at yourself in a mirror, and there's always these weird discontinuities because the lens itself changes the refraction of the light. So these kinds of things are normal. This is actually a nice little detail, okay? So it doesn't necessarily know why people would wear glasses, but it does understand something about the optics. Again, by seeing, a gazillion photographs, in its training database. All right. There are, in fact, 2 errors in this that I spotted fairly quickly. One of them jumped out at me. The other one took me a couple moments to recognize. And one of them I'm going to leave for you to find. And you can talk about this in a comment or an email or something. But the more obvious one has to do with this shirt. Now, as I mentioned, I almost always wore, button-down Oxford shirts. This is a button-down Oxford shirt, but the collar isn't buttoned. Okay, here is the button right here. That's the button for the collar. Now look at the collar. There is no little slot for the button. The AI doesn't know, it doesn't understand the concept of a button-down shirt, or even of a button for that matter, and that a button would have to have a matching little slot for the button to fit into. Right? So this is the collar from, sort of a free collar, non-button-down shirt, but here's the button from a button-down shirt. So it's like, what? That's the kind of thing that happens because, like I said, there is no background knowledge here. It doesn't understand things. It's not so much artificial intelligence is what I would call computational mimicry, right? It can see things, and then it just sort of mimics that based on this huge database that it has. A database, by the way, which is essentially culled from the internet without any kind of approval from the owner of that material, which is a whole nother problem that I won't get into. Continuing with our little button excursion. So this button right here for the collar is a little oddly shaped, and you could maybe just toss that away and say, well, it wasn't very good in terms of the rendering of the picture. Okay, fine. But this button still needs a little slot, just like this button did. And that should be right here, right around this axis. And there isn't one. So here I've got a shirt with buttons, but there's no way to button them. Right? So maybe not so good. Right? Okay, I don't really consider that intelligent. All right? But in any case, given that, let us go back to the circuits that we want to see, okay? So again, simple image search, nothing to do with AI out here. So here's our voltage divider. Here's our little Class B amplifier. So the first thing I do is I go in and I say, okay, let's go and do the voltage divider because that's the simplest thing, okay? And here we go. So I went to, I forget the name of it, but I went to one of the more popular AI sites, put in that prompt, right? The prompt I put in was this, an electrical circuit schematic for a 2-to-1 voltage divider. And what I got was this. So I don't think so. Right? I mean, this is vaguely electrical schematic looking. Like I got a round thing over here that maybe could be a source. Could be a voltmeter. I don't know what the heck this is. This thing kind of looks like a resistor, rather poorly drawn. I don't know what this is, but apparently little solid triangles are bigger, greater than little solid circles, right? And here we have just sort of an orphan resistor hanging out here in space. So this is kind of a parallel circuit, which certainly isn't going to get us a voltage divider. And then we've got what appear to be diodes that are like broken, maybe? I don't know. They're missing parts or maybe just arrows. I don't know what they are. But this one is a go, right? This one is a go. But this circuit is not a go. It's definitely not so much. And we have some kind of weird cryptic thing down here that looks like text but isn't, right? Okay, so again, this is what I'm asking for, an electrical circuit schematic for a 2-to-1 voltage divider. What a mess. I go off to another place and, another site, and this is what I get from there. Hello. I kind of like the yellowed background. Like this is something from the patent office, from 1963 or something like that. What is this? I have no idea. There's just boxes and lines. Nothing's really sensible here. What is it? Your guess is as good as mine. And then we get to this. My first reaction when I saw this was like, mighty Zeus sitting on a kayak paddle. What do we have here? This is some kind of like steampunk nightmare. I don't know what this thing is. Are these tubes? Are these like glass pressure vessels? Are these gauges? Actuators? Relays? I have no idea what this thing is. It looks kind of interesting. It does probably, like I said, belong in some kind of steampunk themed movie. I do like that they put it in this interesting frame, right? But is that a 2-to-1 voltage divider? Yeah, not so much. Okay. So far, we're not doing that well. Again, this is what we got from the image search. So maybe we need something a little bit more specific. Maybe this was just too generic. So let's go over, remember this one, the prompt I used on that was electronic circuit schematic for a Class B audio power amplifier. Okay, that was my DuckDuckGo search. Image search got me this. So let's go see what the AI people give us. Remember, they've probably seen a gazillion of these things. All right, so this is apparently broken because nothing is connected here. I guess you could say these are maybe resistors or inductors or some weird cross product of them. Maybe these are resistors. Switch contacts, maybe. Just lots of lines that go nowhere. Okay, this little gray box has something in it. Could be a lamp, could be a transistor. I don't know what that is. But apparently we do have this little box over here, whatever this round thing is, and is nicely secured with 4 screws from the looks of it, or 4 rivets. Definitely not a Class B amplifier, though. I can say that much. Okay, so we go off to another site, and let's see what we get from there. Ooh, that's pretty, right? Doesn't look like any Class B amplifiers I've ever seen. What does it look like? To me, my first reaction was it was kind of like maybe the aerial view of some like Victorian exhibit space or university or something like that. Like here's the main hall. You know, you're looking down on this from a hot air balloon, I guess. The main exhibit hall, you know, central building, administration building or something for the university. I don't know, maybe that's the science hall, the Hall of Science over here. Athletic fields, maybe, you know, gymnasium. Maybe this is maintenance buildings. I don't know, right? Your guess is as good as mine. It's crazy. And we've got all of these like little things over here, like little terrace lines and stuff. Interesting to look at, not too useful from a design perspective. Okay. And then, you know, let's go to another place and see what we get. Hey, there you go. So let's just dispense with the idea of a schematic, and we'll just kind of give you a generic sort of made up picture of some kind of internal circuit board thingy. Like what are even these components? Maybe these are capacitors. Maybe these are capacitors. But like, why are they on another little circuit board? Right? On their own little circuit boards? And like, what is this? They kind of look like heat sinks maybe, or I don't know. Maybe they're like just miniature models of skyscrapers. I can't really tell. You know, and then lots of what maybe could be surface mount components. Just stuff, right? I mean, yeah, I guess it's a nice picture. You could use that for the cover of a book or something, right? But, oh, and by the way, it does do the nice little depth of field out of focus deal, right? Nice in focus, out of focus. So, you know, it's got that down. But I guess the bottom line here is, at least in its present form, don't think you're going to do an image generation that's going to give you back some kind of variation on a circuit schematic. You know, I would imagine that down the road at some point, in a much more specialized, refined kind of thing, we could create some kind of engine that would understand the concept of resistance, or at least recognize what a resistance symbol is, right? A symbol for a resistor or a transistor or a capacitor, whatever the heck it is. And based on large schematics and some simple rules, maybe could assemble something that was similar to something that is already in existence, sort of a derivative of that. And then you could maybe run that into a circuit simulator and see if you get what you want. It doesn't seem very efficient, right? It might be inexpensive, right? If the computational load was cheap enough, right, in terms of what it would take. But it's really just derivatives of stuff that's already out there, and maybe it'll generate something that's actually useful, right? But you're certainly not going to get anything that's useful just going out and using an AI, image generator and hoping that it's going to look out into the internet and find these examples of circuits that you're interested in and, you know, generate something for you, right? That's why engineers get paid, right? It's because they understand what's required and how to do it, all right? So, well, anyway, I hope you've had a little fun with this. I know I have. And who knows what, you know, this technology will bring in 10 years. But when you read these stories about AI doing these crazy things that's going to put everybody out of work, take it with a grain of salt. You know, money is to be made out there. And, you know, you can just think backwards of all the things that were going to change everything. Everything is different now because of Web 3.0. Really? No. Everything's different now because of NFTs. Really? No. Everything is different now because of crypto. You know, like really, like what's the use of crypto? Okay. As far as I can determine, it's good if you want to launder money or you want to purchase illegal goods or services, right? And you don't want a paper trail. As far as regular currency, I don't really see the advantage of it. But certainly it hasn't changed everything like the hype cycle would indicate. Okay. Things will certainly continue, and we'll see what eventually happens. And these certainly are nice pictures. I'm not gonna argue that. I mean, hey, you need to generate, a quote unquote photograph of somebody. It's pretty good at this, right? Of course, that's what these things were designed to do. But again, they're not perfect. Okay. All right. Well, I don't want to leave you with that. We'll leave you with what we were really trying to get. And if you really want to get this, well, just keep watching the videos. Just keep reading those free textbooks I've got, and you'll know how to do this. All right? Okay. Just remember, 2 wrongs do not make a right, but 3 lefts do. Till next time, have a good one.